Another exciting edition of mathematics being made easy. So today we want to look at this interesting topic, rules of differentiation. So we have a lot of rules as far as differentiation is concerned. So the first thing that you meet in calculus 1 for differentiation is the differentiation of equations using the first principle. And some equations are very difficult to differentiate using the first principle. So with that, these other rules came on board to help or to assist in solving that problem. So we want to look at other ways of what solving differentiation questions or differentiating equations using other rules. So the rules that we are going to talk about today are as follows. So the first rule is the what? The power rule. The power rule. Then the second rule is the quotient. Quotient. Quotient rule. Then the third one, we have the product rule. The product rule. Then we also have the fourth rule, which is the chain rule. So these are some of the rules that we'll be talking about in our lesson as far as the differentiation is concerned. So we have the power rule being the first one, then the quotient rule, product rule, and then the chain rule. So come with me, let's dive deep into solving equations or questions involving the power rule. So this is the first differentiation that we are going to look at. How is it used as far as issues or questions concerning differentiation is concerned? For instance, if a question is given to you, or let's use variable, if y is equal to x exponent n, we know that the x is the base and the n is the what? The exponent. How are we going to differentiate this? When you want to differentiate this thing, the power rule says that this can equally be written as y prime, or it can be written as what? Dy over dx, meaning that we are differentiating with respect to x. So the power rule says that if we have an equation like this, x to the power n or x exponent n, what we are going to do is that drop the n. We will drop the n. So we drop the n. You know that every variable has a coefficient of 1, but it won't be written here. So we drop the n. Then what do we do? We repeat the x. So meaning that the n is now multiplying the n. Then what do? We subtract 1 from the exponent. Here we know that the exponent is what? Is n. So subtract 1 from the exponent, it is n minus 1. So this is what it means to differentiate using the power rule. In another way, for instance, if an equation is given to you, say y is equal to ax exponent n, what do? Our dy, we are differentiating, mind you, differentiating with respect to x. So what do? This is a constant. This is equally a constant. And this is a variable. The a is a constant, x is a variable, n is a constant. What do? We drop the n to come and multiply the a. So we have a multiplying the n. A, the dots here signifies what? Multiplication. So a is multiplying the n. Then I told you early on that we need to subtract 1 from the what? the n. So we bring our x. This is our x. Then we subtract 1 from the exponent. So n minus 1. So what do we have as our final answer? So our dy over dx is equal to a multiplied by n gives us what? A n x n minus 1. So this is just the simple way of what? This is just the simple way of solving or dealing with questions involving differentiation as far as the power rule is concerned. So for us to get it clearer, let's take sample questions and see how we will be able to solve it. Okay, so these are some sample questions involving the differentiation using the power rule. How do we solve these questions? How are we going to solve these questions? So let's take the questions one after the other and let's solve it. So our first question, y is equal to x squared. Y is equal to x squared. What do? I told you early on that our y, if we want to differentiate with respect to x, our dy over dx is equal to, we drop, because there is 1 here, coefficient of 1, which normally we don't write. So when you drop the 2, we have 2 multiplied by the 1 there is the same 2. So x, we bring our x. Then I said we should subtract the 1 from the exponent. Subtracting 1 from the exponent. So 2 minus 1. So our final answer for dy dx will be equal to 2x. Then 1 out of 2 will give us 1. But you know, in mathematics, when it is like this, we don't write it. We don't write the exponent 1. So our final answer will be 2x. I hope you are getting the point. So when you differentiate x squared, you will be getting 2x. 2x as the final answer. Let's take the second question. The b, which is y is equal to 3x to the fifth root to the exponent of 5. So our dy dx will be equal to, here we have a constant here. So this 5 will drop it to multiply the 3. So we have 3 multiplied by the sign means multiplication. Multiply by 5. If you like, you can put it in brackets. If you don't like, you can leave it open as this or like this. Then we bring our x. Then I told you to subtract 1 from the exponent. So here the exponent is 5. When you subtract 1 from it, then we have our final answer for our dy dx will be 3 multiplied by 5 gives us 15. Then our x, we bring our x. Then 1 out of 5 gives us 4. So when you differentiate 3x exponent 5, this is what you are going to get. You get 15x exponent 4. 15x exponent 4. So that is it. Look, you will see how simple it is. Now let's take the last but not the least, c, which is y is equal to negative 5x. Our dy dx will be equal to, you know that every variable has an exponent of 1. And every number also has exponent of 1. So we can have 5 standing on its own. But this 5 has an exponent of 1. We can have 1,000 standing on its own, but it has exponent of 1. But it is not written. It is mostly not written. Likewise, when you have any variable, say a has an exponent of 1, b has exponent of 1, c exponent of 1. In mathematics, but most of the times, it is not written. It is only when it raises to the what? To the power of 2, or an exponent of 2, exponent of 3, say a squared. That is when the 2 is written as the superscript. So, with this, what do? I said there is an invisible one here, but it is not written. It's not written. So what we do is that we multiply the invisible one with the negative 5. So we have negative 5 multiplied by 1, the invisible one. The multiplication, let me use the dots to bring clarity. So negative 5 multiplied by 1. Then we bring our x. We already know that we have 1 here. Then you subtract 1 from it. Subtract 1 from it. So what do we have? Negative 5 multiplied by 1 gives us what? Negative 5. Now, let's shift our attention to x to the power, or x exponent 1 minus 1. X exponent 1 minus 1 will give you what? 0. It will give us 0. This is not our last stop. We can still do something. Our indices tells us that any number or variable that raises or that has an exponent, or its exponent is 0, it is 1. For instance, so if we have something like this, a exponent 0 is equal to 1. We have 10,000 or 1,000 exponent 0 is the same as what? 1. So the whole of this thing, x exponents 0 is the same as 1. So we have what? Negative 5 multiplied by 1. So you know that negative 5 multiplied by 1, that our final answer will be what? Negative 5. So our dy dx is negative 5. I believe you've gotten it. Let's go to some other questions. That we see how or what we can do. Examples of the power rule again. So we need to differentiate all these functions. We have a up to d. So we have the first function, which is y is equal to positive 6, or y is equal to 6. How are we going to differentiate a constant? It is also another thing that we need to look at. So this is how we do the differentiation of a constant. Our y is equal to 6. This can equally be written as, this you can equally write it as 6 x exponents 0. Why should we write it like that? We can equally do that because we said early on that any variable or number that has an exponent of 0 is 1. So it means that the whole of this thing here is 1. And 1 multiplying 6 is the same 6. So don't be confused. This can equally be written as this, telling us that any variable that raises to an exponent of 0 is 1. So our y is the same as, this can equally be written as 6x exponent 0. 6x exponent 0. So now let's go and differentiate. So our dy dx will be equal to, you know already, we drop our 0 to multiply the 6. So 6, the dot signifies multiplication. 6 multiplied by 0. Then we have our x to the power of what? 0. Then I told you that we should subtract 1 from the exponent. So subtract 1. So what do we have? Our dy dx will be equal to 6 multiplied by 0. It will produce 0. You already know that. So x, this will give us negative 1. X exponent negative 1. Negative 1. Negative 1. So what do we have? You know that this negative 1 can equally be written as 0 over x. This can be written because this is a negative. So it is 0 out of what? X. And this thing will give us undefined. When you use your calculator, you get undefined. So 0 multiplying by any variable gives us 0. So that tells us that when you are differentiating a constant, the final answer is what? 0. This one should be at the back of your mind. anytime you are being asked to differentiate a constant, you know that it is 0. So you don't need to even write it at all. It is 0. Are we getting the point? Are we getting the point? I believe you've gotten it, or you got it. Now let's take the second person. Y, which is the b. Y is equal to 1 over x squared. When you see this thing, you don't need to run away from it. Embrace it. So, how do we go about it? We can rewrite 1 over x squared as y is equal to x negative 2. Indices. Now we can manipulate it. So our dy over dx is equal to, we drop the 2, negative 2 to multiply the positive 1 here. So we have, when you do that, you will surely get negative 2. So negative 2x. Then we subtract 1 from the 2. So this negative 2 minus 1. What do we have? Our dy over dx will be equal to what? Negative 2x. This will give us what? Negative 2 minus 1 gives us what? Negative 3. Then our final answer, when you leave it like this, is equally correct. But you want to show maturity in mathematics a bit, then you can write negative 2 out of x exponent 3. Negative 2 out of x exponent 3. So when you are given this equation or this function to differentiate, when you use the power rule, this is what you'll be getting. Negative 2 out of x exponent 3. Now the fourth question. The fourth question, which is y is equal to 4 all over which x? Over root x. Okay, so let's tackle the d before we tackle the c. Let's tackle the d before we tackle c. So this can equally be written as 4 all over x exponent half. This is a square root, which is what? Exponent half. It's not anything. So don't see square roots and start running away from it. It's not anything. This is just the same as this. So, and you can rewrite it again as y 4 exponents negative 1 out of 2. I hope you are following. This can be written like this, and finally can be written like this. So when it is in this stage, the final stage, that makes our differentiation very easy. 1 out of 2 negative. So what do? Our dy over dx, we drop the negative 1 over 2 to multiply the 4. So we have 4 multiplying, let me use the dot, multiplying negative 1 out of 2. Then we bring our what? X. Then we subtract 1 from negative 1 out of 2. What are we going to get? If we subtract 1 from negative 1 out of 2, let's do the rough work. 1 out of 2 minus 1. What do? We can use the butterfly method to get the answer. Let's go through the common method, which is we find the LCM, which is 2. So 2 will go here 1, multiply by negative 1, we have negative 1. Our minus, this is over 1. This will go here 2. 2 multiplied by what? Negative 1 is negative 2. So we have negative 3 over 2. So this one is a rough work that you need to do. So it's negative 3 over 2. So we have negative 3 out of 2. I hope you are following. Now let's move forward. This will go and cancel. So 4 negative 1 2 x negative 3 over 2. This will go here 1, go here 2. So we have 2 multiplying negative 1. This will cancel negative here. So we don't write the negative, but there is negative 1 here. Then we bring our exponent, negative 3 all over 2. Then what do we have? We now have negative 2 x exponent negative 3 all over 2. Then this can equally be written as negative 2 all over x 3 on 2. Finally, our dy dx will be written as negative 2 all over root of x to the third power. Root of x to the third power. So when you differentiate 4 over root of x, it is nothing but negative 2 over root of 3 to the power 3, or exponent 3. So that is it. Now let's combine the variables and then the numbers, and we'll solve some other questions. C, which is y is equal to 6 root x. This can equally be written as y is equal to 6 x exponent 1 out of 2. So how do we differentiate? Our dy dx is equal to, we drop our 1 out of 2, which is hard, to multiply the 6. So 6 multiplied by 1 out of 2, then 1 out of 2 minus 1. You subtract 1 out of 2. Then our dy over dx will be equal to 2. We'll go into step 1, go into 6 3 times. So we have 3x. So 3 multiplying by what? 1 versus 3. Our x is here. Then 1 out of half. It will still give us negative half. It will produce negative half. So what do we do? Our dy over dx will be equal to 3. This can be written as what? X 1 out of 2 to the exponent 1 out of 2. So finally our dy dx will be equal to 3 over root x. So that is the differentiation of 6 multiplied by root x. When you differentiate this thing, this is the final solution. Now we also have to differentiate. The first one, which is a, which says what? Y is equal to 3x cubed plus 4x squared minus 5. What do we do? Our dy dx will be equal to, I told you that draw the 3 to multiply the constants here. So we have 3 multiplying 3. X exponents, we'll subtract 1 from this 3. So 3 minus 1, put it in bracket, plus 4. This 4 being multiplied by what? 2. We drop the 2. X, subtract 1 from the 2, minus, you know that anytime we are differentiating a constant, we always have 0, which I already demonstrated. So this will produce what? 0. So we leave it. Then 3 by 3, this has what? 9. X, you subtract 1 from 3, you have 2. Plus 4 by 2, this has what? 8. X, you subtract 1 from 2, you have 1, but we don't write it. So finally, our dy dx will give us this, 9x squared plus 8x. The second question, B, which is 4x squared in 4x to the 4th power plus 2x to the 3rd power plus 3x squared. So our dy dx will be equal to 4. You drop the 4 again to multiply. 4. Then our s, you subtract 1 from 4. So 4, 1 out of 4. Then we move to addition. Then we have what? We bring the 2, multiply by 3. Then we have what? 3 minus 1 plus, you drop the 3 to, sorry, the 2 to multiply the 3, which we have what? 3 multiplied by 2 x. Then we have what? 2 minus 1. So when you do the multiplication, well, 4 by 4 gives us 16. 16x. Here will give us 3, exponent 3. Plus this will give us 6. X. The exponent will be 2. Then we have plus this will give us 6. Exponent 1, which we don't write. So our dy dx for this solution, or for this question, is this 16. Sorry, the second question will be 16x cubed, 6x squared, and 6x. So the fourth question, or the C. Oh, okay. So can we continue? Okay. Okay, so this is another question that we need to solve. How do we solve this question? Y is equal to 9x to the 6th power. Then all of this divided by 3x squared. When you see this question, you shouldn't fumble at all. This is the same as this. 6 plus 12x4 plus 6x squared. All over 3x squared. So our y is the same as 9x exponent 6 over 3x squared plus 4x exponent 4 over 3x squared plus 6x squared all over 3x squared. Or better still, you can factor 3 out so that it will be easy for you. Factor 3 out. We'll use the 2 matrix. So what will happen is that you can see that 3 can go into step 1, go into 9 3 times. So we have 3 here to go 3. This exponent will cancel. So we'll be left with 4. So we have exponent 4. Then this 3 will go into step 1, go into 12 4 times. So we have 4. This will cancel. So we have 2 here. 4 exponent 2. Plus 3 will go into step 1, go into 6 2 times. 2. Then this 2 will cancel. So here we'll be having, or we'll be left with a constant. I hope you are getting the point. So now we are good to go. With what we have now, we are good to go. So 3 multiplied by what? We'll drop the 4. X, we subtract 1 from the 4 plus 4, then we drop the 2 to multiply the 4. 2x, then we subtract 1 from the 2 plus, we know that differentiation of a constant, so now let's multiply. 3 by 4 gives us 12. X exponents, subtract 1 from 4, you have 3. Plus 4 multiplied by 2, you have 8. X, subtract 1 from 2, you have 1, which we don't normally write. So this is the answer to the question. This question. This is the answer to the 9x exponent 6 question. Now let's look at the final question. The final question. So which is y is equal to x squared minus 1 multiplying x plus 3 all over x minus 1. This is the question. How do we differentiate this? You know that this is, when you look at this thing, this is a difference of two squares. Difference of two squares. For example, if we have x minus 1, x plus 1. When we multiply this and this, it will give us x squared. We multiply this and this, you have plus x. We multiply up minus x, multiply negative 1. This is difference of two squares. So when you multiply, so we have what? X squared minus, x minus 1, x plus 1. So when we expand this thing, we are surely going to get this. So when we expand, what are we going to get? We'll get this, will multiply this. We have x squared. This h will multiply 1. We have x. Negative 1 multiplying x, we have negative x. Then negative 1 multiplying negative, positive 1 will have what? Positive 1. So you can see that this is negative, positive x, and this is negative x. So this and this will do. So we have x squared plus, x minus 1. This and this will give us negative 1. So we have x squared minus 1. So in place of this, we are going to use this. In place of x squared minus 1, we'll expand the bracket so that we'll have this. So we can cancel things out. So let me cancel this and put it there. So y is equal to this. I told you early on that it can be written as x minus 1, x plus 1. Then we have our x plus 3 all over x minus 1. So what can you see? You can see that we have x minus 1, x minus 1 here. So what do? This will cancel this. And if this cancels this, what are we left with? We are only left with x plus 1, x plus 3. So we open brackets. This x will multiply this. We have x squared. Then x will go and multiply 3. We have plus 3x. 1 will go and multiply x. We have what? Plus x. Then 1 will go and multiply 3. We have 3. Then our y will be equal to what? X squared plus 3x plus x. This has 4x plus 3. Good. So this is the expansion of this. When we reduce it, this is what we are having. Now let's find the derivative, which is dy over dx. So I told you that when we are differentiating with respect to x, we drop the exponent, which is 2, and there's coefficient of 1 here. So we drop the 2 multiplied by the 1, which we normally don't write. So we have 2 multiplied by the 1, then we bring our x. Then we subtract 1 from the 2, which is 2 minus 1. Then plus, there is 1 here. We drop it to multiply the 4, which is the same 4. Then we have x 1 minus 1. Then the last one I told you that was, if we have a whole number, or if we have a constant, the differentiation, when we differentiate it, we'll get 0. So check my other videos or check the beginning of the lesson. You will see a tutorial done on this. So finally, we'll be having what? Our dy over dx will be equal to 2x. This will give us 1. Because when we subtract 1 from 2, we'll have 1 here. Plus, this will give us 0. So we have 4. This will give us 0. X to the power 0. So finally, we'll have what? 2x finally we'll have 2x plus this will give us 1. So 4 multiplied by 1 gives us 4. So this is the solution for the final question we have on the power rule. We have so many questions. So we have so many questions on the power rule. So this is the final question I've solved. If you have any other questions which is bothering you, you can kindly drop it in the comment section, and let's see how we'll be able to solve it for you. So thank you very much for watching, and when we meet again, we'll continue with the products rule. Thank you.